Hi everyone, I'm Barakat from RTA Care and University of Luxembourg. I will be presenting this work in the space of art therapy, an ongoing work efforts we've been doing to support art therapy with recommendation system. This work is done with my colleague Luis Leiva from University of Luxembourg. So to give you a little bit of context about art therapy, it's an established clinical practice to support patients with psychiatric sequelae or mental health issues like anxiety, depression, or PTSD. So particularly a visual exposure form of art therapy starts by first exposing patients with visual stimuli and complete a task, basically to identify elements that will help them recall healing their traumatic experience or elements that will support their healing journey. And therapists will use this information to find paintings or visual elements to drive recommendations and then create a guided art therapy session. So the first challenge here is essentially, it's a quite difficult task for art therapists to find a personalized piece of art for patients. And this is where we started working on for the past few years to introduce visual art recommendation systems to support the creation of guided art therapy sessions. So this work is particularly part of a train of works we've been doing over the past few years. We have been trying to use a bunch of algorithms that are basically trained for visual art recommendation in the art therapy space. And this paper is particularly a direct extension of the AI Therapist Duo paper, which basically brings a human-in-the-loop approach to create art therapy sessions. So what happens essentially in the AI art, the therapist duo is essentially patients will go through a preference elicitation kind of phase where they complete a cognitively demanding task to identify elements in the visual stimuli, and then there will be a recommendation, and therapists will work with the recommendation system to create a guided art therapy session. So the key research question for this paper is essentially, can we make it easier for patients? This is a cognitively demanding task, the first part of engaging with visual stimuli and identifying elements. And these are patients with mental health issues. So what can we do better? And our research question is essentially, can we use music instead of a cognitively demanding task? So as we all know, music has a power to evoke emotions. We all have our preferred playlists where we go to whenever we feel low or sad. So can we do something better with art therapy? So the first thing we do is basically for cross-domain recommendation is essentially look for data sets. And the only publicly available data set for in the music therapy domain is DIM with affective annotations. And in the art space, the only thing we could find was Wiki Art Emotions, paintings with therapeutic or nature-based paintings with emotion labels, not affective labels. So the first thing is basically making the labels similar and then doing a cross-domain recommendation task. So what we did essentially is we proposed 3 family of recommenders for affect-aware cross-domain recommendation. The first one is essentially starts by extracting modality-specific features from both paintings and music, and then there will be a representation space, which is very high dimensional, and we used autoencoders to reduce the dimensionality, which is trained with reconstruction loss to preserve expressiveness. And then finally, we concatenated the direct valence and arousal values so that affect can be part of the explicit representation space. And then we created basically a joint embedding space with contrastive alignment. And recommendations can be driven from this joint embedding space. The second is a rather deliberate simple baseline, which does not use any of the features that are specific to the modalities. We work with only affective labels, so this is an affective space search. Simple, understandable. And the last one is a complement that complements both of these approaches using large language and vision models to generate semantic descriptions on top of the feature-based information from both modalities. And in the end, we get a representation space, which is a joint embedding space, and we drive recommendations. And we named them Mozart, Haydn, and Salieri. This is taken from the famous musicians Mozart, Haydn, and Salieri. These are not just classical composers, but contrasting philosophers representing brilliance, balance, and rivalry. So, do they work in the therapeutic context? So, the ultimate judge is a user study. So we conducted a clinical study which is a large scale with patients diagnosed with psychiatric sequelae and specifically anxiety, depression, PTSD, ADHD, bipolar disorder, and eating disorder. And it was a between subject design where 50 patients were assigned to one of these groups where the guided therapy session goes with paintings recommended by music-driven preferences. So before therapy, we administered standard psychological measures, including patient health questionnaire, and the preference elicitation was done by music for music group and the classical cognitive task with paintings. So, and then patients go through guided art therapy session prepared by a licensed art therapist. And then we also administered after the session measures post-therapy impacts. So, what did we find? The results interestingly show that music-driven preferences actually performed as good and in some cases even better than the visual baseline. Interestingly, across all music groups, we also found mood improvements. Negative moods went down from 46 to 11.5%, and positive mood increased to 72%, which is quite high. And also, in terms of affective measures and PANAS, there were significant improvements in this approach. And we did a bit deeper analysis into the reflective thematic analysis of response of the patients, and hope was the most common theme across all healing concepts discovered by patients. And specifically, Salieri particularly showed a strong therapeutic resonance with hope. So, one clear observation is that there was no clear winner across the three family of cross-domain recommenders, but we solved the problem of this cognitively demanding task. So this means essentially therapists, without bothering patients or asking them to complete a cognitively demanding task, they can create therapy session by simply accessing their music playlist or Spotify or anywhere where they can have music information. So music preferences provide a more richer and more accessible entry point for the therapeutic process. And potentially a future work would be doing the inverse in music therapy. This is a completely different domain, which is rather unexplored in this space. So just if you are curious, as a conclusion, we are doing a demo tomorrow. So at RTI Care, it's a digital art therapy platform where we support art therapists with digital tools and technologies. We don't only provide recommendations, but we also use neural feedback to assess the impact of therapy. So if you are curious, tomorrow I invite you to stop at our spot where we are demonstrating this tool. So you can have a free digital art therapy. And by the way, today is Art Therapy Day in Europe. So yeah.
So one question is, how do you make sure that your cross-domain recommendation models captures actually effective responses and not just some correlations between art and music preferences?
Which one? Any of them?
Yeah.
Okay. So you can find more details in the paper, but the three different cross-domain recommendation models, especially Salieri, the middle one, which was using only valence and arousal values, these were annotated by users. So there is inter-user agreement in the representation of this valence and arousal, but the first model, Mozart and Haydn, but essentially try to extract values or representations. For example, if you have a painting, nature, water, or leaves could drive some kind of emotional reflection for people, and art is complex, so the kind of emotional and cognitive reflections that triggered by the same piece of art for different people is different. It's subjective, really. So the cross-domain recommendations, we try to expand or capture as many information as possible, even using LLMs to generate captions and semantic descriptions as possible to complement the user-reported valence and arousal values. So it's not yet enough, but this is the best information that we could capture to train these cross-domain recommendation models. But the user study shows that they are as good as the visual stimuli.
So how does it compare with an LLM? So nowadays, generalist LLMs can provide quite relevant recommendations and are also conversational.
Yeah, well, we are not using generative images. These are actually real images. So LLMs can suggest existing work, but I'm not sure if the question is referring to generated images or just recommendations with LLMs.
I can also, but maybe that LLMs out of the box can already do a lot today. This might be the question.
Yeah, but the space, I mean, if you go to artaik.com/research, you can find all the train of papers, but something that stands out, especially in the AI therapist duo, is essentially there are a lot of risks associated with using only recommender systems without human oversight.